So let's talk about the proof of the power series equation, how we derived the power series equation and from where we have derived. So let's do a short mathematical and graphical proof. If you are familiar with the Taylor series, it is a Taylor series which is f of x equals to f of c plus f prime of c over 1 factorial into x minus c plus f double prime of c over 2 factorial into x minus c to the whole squared plus f triple prime of c over 3 factorial into x minus c to the whole cubed plus so on. It goes up to infinity. So we can write f to the n of c over n factorial into x minus c to the n. This n can be any number. You can go for the 4, 5, 6 up to infinity. So it is a typical Taylor series equation. We're gonna derive the power series equation from here. What Taylor series do? We do approximation with the help of the Taylor series. So let me show you graphically here. This is my xy plane. If I have a sine wave here, now let's suppose for the first four sum, which is 1, 2, 3, 4. Let's suppose for the first four sums I approximated the sine wave such. If I increase more sums, well, better approximation now. And then when I increase more, I will have more better. And if I increase more, I will have much better approximation compared to the last one. Look, as I said, with the help of the Taylor series, we approximate some values. If I have a sine wave in the xy plane, I want to approximate this value. I need some information of the sine wave. So I need to study its properties and I need to approximate it. We already know that Taylor series is an infinite series. It goes to infinity. It is helpful to approximate something. The more we have the sums, the better we have the approximation. The more we have the sums. Suppose I want to approximate the sine wave. So for the first four sum, 1, 2, 3, 4, I approximated just this region. And then when I increased the sum, suppose I approximated the sine wave a little bit better than the previous one. And then when I increased more, I approximated it slightly better than the previous one. And then when I increased more, at this stage I have a better approximation compared to all the previous ones. As I said, suppose for the first four sums, I have such approximation. And then after increasing some more sums, I have better approximation. And then when I increased more sums, I have slightly better compared to the previous one. And then when I increased more, I have much better approximation now. So by increasing the number of sums, like n can be 50, 40, whatever value you have up to infinity, the more you have the number of sums, the better you will have the approximation. That's what we do in the Taylor series. Now we're going to apply the exact logic for the power series. This is the equation of the power series, which is f of x equals to summation of a sub n into x minus c to the whole n, where n starts from 0 up to infinity. For this part, it behaves as a constant. Let's suppose this is my a sub n, a sub n, a sub n. So for this part, I put a sub n. It is a coefficient. It can be a constant number and can be in a complex form. The rest of the part is the same, which is x minus c. So it is x minus c to the whole n, x minus c to the whole n. It starts from 0, n starts from 0 up to infinity. Look here, I have f of c into x minus c to the whole 0. So x minus c to the whole 0 equals to 1. 1 times f of c is 1. The first term came out when I plugged n equals to 0 for the power n. That's how we derived the power series equation with the help of the Taylor series. It is the sum of the powers. The sigma means summation of this stuff. Let me show you the summation of some terms. Like at n equals to 0, I have a sub 0 into x minus c to the whole 0, plus a sub 1 into x minus c to the whole 1 at n equals to 1, plus x sub 2 into x minus c to the whole squared at n equals to 2, plus so on, which is a sub n into x minus c to the whole n. You can go more than this, like n can be 3, can be 4, can be 5, up to infinity. Look at here, what this equation means. This equation means that it is the summation. It is the summation of a sub n into x minus c to the whole n. The sigma means the summation of this stuff, where the n value starts from 0 up to infinity. Let's start at n equals to 0. just plug n equals to 0 here, n equals to 0 here to have a sub 0 into x minus c to the whole 0. And then n equals to 1 to have a sub 1 into x minus c to the whole 1. And then at n equals to 2, just plug in 2 here and here to have plus a sub 2 into x minus c to the whole n, plus so on. Make sure don't forget the summation sign. It is the summation. The sigma means the summation. It is the summation of this stuff. So it equals to a sub naught plus a sub 1 into x minus c to the whole 1 plus a sub 2 into x minus c to the whole square plus so on, plus a sub n into x minus c to the whole n. This n can be any number. Look, x minus c to the whole 0 means 1. Whatever thing you have, when you take the power 0, it equals to 1. So this whole thing equals to 1. 1 times a sub 1 is a sub 1. The same logic applies here for the first term in the Taylor series. This is the typical power series which goes to infinity.